All right, guys. So this is part 2, building on what we were talking about in part 1, where we're talking about the chords properties in a circle. So for this example right here, it says find the values of x degrees and y degrees. And right here, it has the by the chord properties. So if I were just to draw a line right here, so the first one is all about the chord properties. So the first thing we have to do is we have to look at this symbol right here that I'm going to circle in red. That's the bisector line. So we need to know that in this first space, we would put OC bisects line AB. Okay, so x degrees, obviously, from our example, is going to be 90. Oh, excuse me. By the angle sum property, so once we have that figured out, we know that all the degrees in a triangle, or all the angles, equal 180. Oh, that's a terrible 8. And then we would subtract 90. And we already have the 40 in there. So once we do that, we have 180, subtract 90, subtract 40 is 50 degrees. So angle Y, which should be right there, is equal to 50 degrees. Now, as we move forward, the same thing will take place when we're looking at this one right here. Okay, so again, we need to say that OC bisects line AB. So this x degrees right here, because we need to find x, y, and z, is going to be 90. So we did that by the chord properties. Then we have the angle sum property right here, which is 180. Subtract 90. They give us a 55. 55, which is equal to 35 degrees. Now it says since OA, so that's OA, equals line OB, and triangle AOB is isosceles. So then the angles OAB and OBA are equal to each other. Z is going to be 55 degrees. So that's what that's talking about right there when they're talking about chord properties and angle sum properties. If we just whip over here to this side of the page, this is using the Pythagorean theorem. Now, again, we have a triangle. Now, it does create a triangle in here, and eventually we're going to be doing that other side right there. So we have a squared plus b squared, so we would use the Pythagorean theorem for this. So other words, a squared plus b squared equals c squared. We have the two measures of that, which is 10 centimeters and 6 centimeters. We follow the directions. So they're just giving us the lines there, by the way, where it says BC squared. It doesn't really matter which you put there. We square those two things, 10 and 6. We subtract those from each other. We get 64. Take the square root of that. And the line right here is equal to 8 centimeters. Now, believe it or not, because this line is a chord, and that's half of it, we can get the full distance out of there just by using the chord properties or just doubling or times that by 2. All right, so that's how we would do that by using the Pythagorean theorem. What does that look like in practice? Same thing here. I just put the example right here. So if we were to use this in practice over here on this side right here, oops, so we do that. We would do the same thing. So we would do the Pythagorean theorem through the whole thing. All right, so in this case here, we have 13 and 5. This is the hypotenuse. This is one of the legs. And we're going to be trying to figure out what the length of A is there. So in this case here, what do we have? 13 squared, and this is 5 squared. So 13 times 13 is 169 equals 25 plus A squared. We take 169, subtract 25 equals A squared, which is 144. Take the square root of that, gives me 12. So that's 12 centimeters. So we have E, G, and F, G. We'll go on these lines right here. E, G, and F, G. So the length of, so B is 12, just like that. That's pretty straightforward. We'll be talking about that probably on your assignment. It's fairly straightforward. You just have to name all the radii, diameters, and the chords. Okay. We're going to be moving on to an assignment. Probably get that later this evening for all you Nighthawks out there. And we'll talk to you tomorrow if you come to the meet. Take care.